Hey guys, this is just a follow-up video from my Power Wheels lift. There was a lot of questions on where to set the auxiliary pulley and how to calculate it. This video is for that. If it's a lot of math, highly math intensive. It's not like my normal. Well, I guess a lot of my videos have a lot of math and everything in it. But if you don't have any interest in the Power Wheels lift at all, then don't watch this video, because otherwise it'd be a waste of your time. But unless you're just curious about it and see how I did it. But anyway, enjoy the video. If you guys do watch it, I doubt this will have 50 views, but hopefully it helps somebody out. Thanks. All right, let me see if I can explain this using my iPad, drawing it out. Hopefully it records all right and you can hear me okay. So I want you to imagine you're laying on your back looking up at your ceiling, and so you're going to have your four main pulleys. All right, and then you're going to have your dead center where all the ropes are going to attach. And if this is a Cartesian plane, we'll say this is 0, 0. All right, and then to the left or right or up or down, we'll say over here to the left, you have the final point, and we'll just say this is negative final. Man, I wish I could try to draw that better. Oh. And the y coordinate would be 0 because it's in line with that right there. Alright, so let me back out. These points, the pulley marks, you're going to have X and Y. We'll just call them X1, Y1. So that's positive up, positive across, and then you're going to have, let's see, X1 comma minus Y1 for this one, and this will be negative X1 comma negative Y1, and this one will be negative X1 comma and negative Y1. Alright, so that means that your distance between these two is going to be 2x1, and your distance between these two, or your length, is going to be 2y1. Alright, so we'll get some of this cleared up. Alright, so we're going to have an auxiliary pulley. I think when I did this, I arbitrarily just said it's going to be, so you need an auxiliary pulley in this area here, in this first quadrant, or was this the fourth quadrant? And also one around this area here. And I went ahead and said that that auxiliary pulley is going to be along this line, and this distance is going to be x1 divided by 2. So it's going to be the midpoint between here and this line. Alright, let me get some of this backed up here. Alright, so we'll just call this this point will be x1 divided by 2, and we'll call this y auxiliary. Alright, now when looking at a main pulley, the amount of rope that gets pulled through one of these pulleys, it's let me think. Okay, you have to do a distance formula. So the amount of rope that gets pulled through from the time that this point moves to here is not going to be that final x coordinate point. All right, it's actually going to be this distance. Okay, from this. Well, let me draw that again. From the pulley to the final resting point, it's going to be that distance that I just showed. This minus this distance. All right, and that'll show how much, and that will give you how much this as it travels that distance. Okay, hopefully that makes sense. All right, so we're trying to find this distance minus this distance, because this is the initial starting point, and then this point moves to here, but the amount of rope being pulled will be this minus this. All right, so you have two distance formulas, and let's see if we can write those down. I'm actually going to associate it with this pulley. All right, because they're positive, it makes it better. So hopefully I can draw this. So we'll call, where's my eraser? Okay, we will call this this right here will be D final 1, and that's the length of that, and we will call this just D main. Alright, so that'll be the distance between the center and the main pulley. So we'll say it's main pulley pull distance equals, what do I say up here, D final 1 minus D main. Alright, and if you remember this in math, it's pretty much the Pythagorean theorem is the distance formula. So D final is going to be square root, and then remember it's the x's minus the other x's. It's, well, we'll just go through it. So let's see, I'm doing D final. So you have x of 1 minus final, so that'd be plus final. Oh. X of 1 plus final. This is a whole lot easier if you already know your numbers. And that'll be squared plus, let's see, y of 1 minus 0, so that's just y of 1. And then we're going to be minusing D main, and that's going to be square root. And since it's going based off the center, it's just going to be x of 1 squared plus y sub 1 squared. I'm just kind of checking my math here next to me. Alright, that should be right. Now we're going to do the exact same thing for an auxiliary pulley. So we'll call this auxiliary pulley pull distance. And that will be, we'll call this D final aux minus D aux. And D final auxiliary will be this distance to the auxiliary, from the auxiliary pulley to your final point, and then the distance auxiliary will be from the center to here, to the auxiliary pulley. Let me erase that. All right. So D final is all right, square root, and we know the x coordinate for the pulley is x1 over 2. So x1 over 2 minus, and you're subtracting negative final, so that'd be plus final. And let's go ahead and square that. Plus, and then you're doing y auxiliary minus 0, so that'd be y aux, y sub aux squared. And then we're doing subtracting distance of auxiliary. And so again, since we're doing it from center, reference in the center, it'll be square root of x1 over 2, and we will square that, and then that will be plus, with the y coordinates, y auxiliary squared. All right, so now we got two distance formulas. Now, the only thing you got to do now is you have to set this and this equal to each other. All right, so if I can shrink this. So I think what we'll do now is we'll go through and we'll assign some values to make this easier. So again, this and this have to be equal to each other, because if the rope pull amount is the same, then your carriage will stay level. Okay. So let me go back. Let's throw some numbers in here. We're going to say that this distance to here is 3, and this distance is 4. So this is a carriage size of 6 wide, 8 tall. All right. And so let me back up. We go down here. So x of 1 equals 3. Y sub 1 equals 4. Then x of 1 over 2 equals 1.5. And we'll say our final distance from the center point to here, so final will be 12. Alrighty, so let me throw this over here so I can work. So we have the main pull. Let's see, square root. Actually, let me delete this. Alright, go back to here. X1, which is 3. Wish this thing would hover a cursor here. So looking at, I'm going to be looking up here in this area. Alright. So square root of x of 1 plus final, this would be 3 plus 12 square, or 3 plus 12 is 15 squared, that's 225. So you're going to have 225 plus y sub 1 squared is 16. And we can simplify this a little bit later. And then minus square root of x1 squared is 9 plus y squared is 4. So 3 squared is 9, 4 squared is 16. Together that's 25. Square root of 25. I'm going to go ahead and simplify this. That's just 5. Let me make sure I did that right over here. Alright, we'll do ahead. See. 225 plus 16 equals, and then we'll square root that. 15,524. That's minus 5. So we got the main pull distance is 10,524. We'll look at the auxiliary now. And this is one that's going to have some values you don't know. And so, again, we're looking at this equation here. Let me move this over to this corner. Switch back to black. So x of 1 over 2 is 1.5. 1.5 plus final is 12. Is that 13.5 squared? 13.5 squared is 182.25. So 182.25 plus y auxiliary squared minus looking over here now. Square root x1 over 2 squared, 1.5 times 1.5, what is it, 2.25? Yeah, 2.25. 2.25 plus y auxiliary squared. Alright, so now we have the equation 10.524, because we're going to set this equation and this equation equal to each other. 10.524 equals 182.25 plus y aux squared minus 2.25 plus y aux squared. Alright, so at this point I tried to find an online equation solver for this, and most of them, they get all confused and they don't know what to do. So I kind of usually just throw this thing into an Excel file and just have a range of numbers. I know that the y position is going to be, let me scroll up to the top, y auxiliary can't be more than your y1 value and cannot be less than 0. So it has to be between, you know, these two points in this range. So you can pretty much just do a spreadsheet of 0 through whatever your y1 is, which is 4 in this case. And we can switch over and to sheets, and I'll show you that. So we'll start out here, cell 1. If I can do this, how do you? Come on. Oh, Google Sheets is the free one here. I'm gonna start a new tab so you don't have to see this. There's no way to do a new tab. Pardon me here, let me. Alright, we'll just clear those out. Okay. So start here. do 0.1, and we'll go to the next one, 0.2. All right. I get that. There you go. All right. So we'll select these two. We'll select this. Jesus. And we'll go down to what, 40. We'll go to 40. I'll do autofill. That does that, and then we set up our formula. So we'll do equal sign. Let me flip over to the keyboard here. Equal sign, square root, and this is that equation we did that's equal to the 10.524. 182.25 plus, we'll just simply call this not y. We'll make the a column our y's. So boom, and we'll square that. So there's that one square root. Get all the way over. We'll minus square root again. 2.25 plus y, which again is at the a column. So we'll go back to A1 and we'll square that. And there's our answer. Select this, and I will be dragging this all the way down. Come back up, tap. There you go, autofill. That sends everything. So we're trying to find the closest one to 10.5, or I'm sorry, yeah, 10.524. And it looks like we're getting between, was that 2.9 and 3? Yeah, that's right. Okay, so now you can redo the column again, except starting out at 2.9. Or I'm sorry, yeah, 2.9, and you could do 2.90, 2.9. We'll just do it this way, 901. We'll go all the way up to 3 this way. Clear this out real quick. What the hell just happened? Back that up. Autofill. Alright, 10.524. So it looks like our answer is going to be 2.928. Alright, so let's go back over here. .928. So what that means is our position from center 0, 0, and here's our main pulley here at, what is this, 3 and 4. Our auxiliary will be about right here, and it will be half this, so 1.5 comma 2.928, and then the other auxiliary will be down here at negative 2.928. And if you want to convert that to, say, I don't know, quarter inches, well, you know, quarter of an inch, where you want to do 16, just multiply the 0.928 times 16, and it'll give us your closest 16th of an inch. 0.928 times 16. I mean, yeah, it's 15/16. So that's 2 feet, 15/16 of an inch. hopefully that explains it. I know it sounds complicated, but I mean, I was sitting there looking at it. I was like, I want this thing to be dead level. And after doing all this, that's how I calculated it. And I did dead level. Hopefully this works for you. I'll hold these equations up here. But I mean, I did all the hard work. Really, it's just plugging and chugging right now. So I don't know if you're still in college or not, or outside, or had any engineering classes. But hopefully this brings back some memories. I couldn't for the life of me figure out how to solve that one. That I know you can, like, the thing that's throwing me off. If this whole thing was square rooted, I was like, oh, okay, that'd be square both sides. But separated, I just sometimes I just do the old guess and check because I could probably do it quicker than actually trying to sit there and solve it. But anyway, all right, thanks for watching.